So the next extension is the volumes of revolution between two curves, which is a fairly natural progression and not too difficult to do once you understand the basic concept. Essentially, we are going to be working out the volume between two curves. To get the idea, I've got a lovely pyramid here from a $1 bill, and what we're going to be doing is trying to work out the volume of this base area here. To do that, we need to work out the volume of the entire pyramid all the way to the apex, minus from it the small pyramid, it's got the eye here, and that would obviously give us the volume of this bit right here. Do need to work out the entire volume and minus the smaller volume to work this out. There's no other way to do this essentially. So in a similar fashion, we're going to try and do the same thing with a curve. We've got two curves, and what we need to do is work out the volume of revolution between these two curves, i.e. this area here. A common mistake is to simply work out this part right here, I'm squiggling away, and then just rotate that about the x-axis. That's no good, unfortunately, because it's not going to give us the entire volume. What we really need to be doing is working out the entire volume under the red curve, the entire volume under the blue curve, and then minusing these two volumes from each other. Very similar to how we just did with the pyramid. So let's try and have a go at this. Well, the first thing we need to do is to work out the limits between which we're going to actually be integrating this. To do that, we're going to need to work out the two intersection points of my curves, which are here and here. Simply do that by equating these two curves to each other, so minus 3x squared plus 12x equals minus x squared plus 5x. Manipulate the algebra a bit, and you should end up with the quadratic that can be solved, which will be 0 equals 2x squared minus 7x, which will give you two solutions. One is x equals 0, and the other is x equals 7 over 2. Now we've got those 2 points, so 7 over 2 and 0, we now need to try and work out this actual volume. Well, logically, it would follow that if we're rotating about the x-axis as we are in this question, we simply need to work out the integral of the first equation. Let's give that a letter, call it y1. The second one, let's call it y2. If we worked out the integral of y1 squared with respect to x, minus from it the integral of y2 squared with respect to x, we would have the volumes. This can be quite nicely simplified down to simply an integral between y1 squared minus y2 squared with respect to x, meaning we only have to do one integration. So first thing we need to know is what is y1 and what is y2, or at least what they're squared. So y1 squared is going to be equal to minus 3x squared plus 12x all squared, which you can simplify out to being 9x to the 4 minus 72x cubed plus 144x squared. Let's do a similar thing with y2 and square it, and that gives us minus x squared plus 5x all squared, which leaves us with x to the power of 4 minus 10x cubed plus 25x squared. Finally, we just need to minus y2 squared away from y1 squared before we even think about integrating, and that leaves you with 8x to the power of 4 minus 62x cubed plus 119x squared. This is the bit that we're about to integrate. We've got our limits because we worked them out earlier, and now all we have to do is go ahead and do the integration, which unfortunately as this video is running out, I'll show you in the next one.